Hi there. Are you interested in history? Because this program is about the history of biology here at the University of Alberta. Not everyone likes history, and after all, biology is part of science, and in science we like to replace the old with the new, to question the past and to throw away the outdated ideas. But you know, I think even the most hard-nosed scientist has some sort of sense of tradition, of heritage, and we all appreciate a good story or two from our collective past as well. So Su Ling, this was my locker.
Wow.
This was my number 72 center wing.
Look at that.
All my stuff's gone.
What kind of stuff would you have kept in here?
You know, I don't even remember. I just think tons of books and notes and things like that. Dissecting tools.
Yeah.
Yeah. My name's John Acorn, and I've been around this place for most of my life. When I was a kid, I was a bug collector and a bit of an entomology department groupie. I could hardly wait to become a student here. I did my undergraduate degree in the former Department of Zoology, my graduate work in the Department of Entomology. We were taught by very accomplished people, and we got a really solid education, and I'm really proud of that. And I've been everything, a research assistant, a teaching assistant, a research associate, a full-time technician, and a lecturer. I've never been a tenure-track professor, but we'll talk to lots of those kind of people momentarily. In any event, I'm happy to be your host on this little trip back through time. When were you here at the U of A?
I was here from 1991 to 1995. I did my Bachelor of Science degree with specialization in zoology. But I don't know how much, I mean, the building certainly hasn't changed at all since I was here, so people are still enjoying the same fine amenities in the Biosci building, that's for sure.
You know, what is now the Department of Biological Sciences was originally 5 separate departments, 4 of which were brought together here in the building, the Biological Sciences building. It's a very quirky building with a mystique of its own. This is room M135. It's a wheelchair ramp with a door at both ends, right angle bend at the top, power outlet. What were they thinking? That's what a lot of people have been asking. What were they thinking when they built this building?
My goodness. There's some very odd things here.
Apparently there was one room, one of the professors was looking at, I believe it was her space, and wondered why this wall was here, and then there was a stairwell over there, actually quite a ways away. And after getting somebody to actually listen to her ideas, they knocked a hole in the wall, and there was a whole room there that had absolutely no doorway to it, no windows, nothing. It was just a walled-in room.
Nobody knew about this room until you pulled out the blueprints and they found the missing room. There's also some very, very weird little staircases to nowhere.
Biology at the U of A. It comes in many guises, but it never goes away. First came Francis Lewis with a stiffish upper lip. Got off from the Royal Society, but by all accounts he was a pip. Alone out on the prairie, his fame spread east and west. Soon hated by his students, silver keeping was the best. Biology at the U of A. It comes in many guises, but it never goes away.
The first biologist at the U of A was Francis J. Lewis. Francis Lewis came here from Britain in 1912 at the age of 37. He was a botanist, and for 10 years, the entire decade of the original Department of Biology, he was the one and only professor. Now in those days, higher education was a new thing in Alberta, and of course they had to look to other places for their instructors. The U of A was proud to be one of the 70 universities of the British Empire, and it was no coincidence that Lewis came from Britain. In a prominent speech in 1933, Lewis talked about how isolated he felt here. He said, "Men of science in this country occupy a very detached position. The Royal Society of Canada meets but once a year for 3 days, and apart from this, Canadian workers are dependent for exchange of views on rare visits to other countries and the publication of papers in societies outside Canada." Francis Lewis was a botanist, and some of his specimens are still here in the herbarium among the 150,000 plus specimens of vascular plants that we have in the department. Look at these beautiful calypso orchids. Lewis found them in June of 1915 in a pine forest on Tunnel Mountain in Banff, and they still look, downright beautiful. He was interested in living plants. He was also interested in paleobotany and the record in peat sediments. And he supervised many students, including the first MSc graduate in biology at the U of A, Gwyneth Tuttle, who worked on the way spruce needles change with the seasons. Look at that. Fantastic.
When they felt the need for botanists, they called on Dr. Moss. Hey, Dr. Moss! Flora of Alberta had a bryophyte for a boss. He sowed seeds of his own science, saw them flower, saw them root. And when the leaves had fallen, he gathered scientific fruit. Biology, biology, at the U of A. It comes in many guises, but it never goes away.
In 1921, the university hired 2 more biologists, Ezra Moss, another botanist, and William Rowan, who was a zoologist. The 3 of them, they didn't get along very well, so 2 years later, they divided the Department of Biology into 2 new departments, a 2-man botany department and a 1-man zoology department. Now, the Department of Botany was formed in 1922 with 2 professors, Francis Lewis, of course, and Ezra Moss. Ezra Moss was a Canadian. That was a nice change, and he got his PhD in Toronto at the U of T. Went on to become a very famous botanist, wrote the first edition of the Flora of Alberta, and he and Lewis were alone until 1939 when they started hiring other botanists. At least that's the official story. That's kind of the old boys version. There was also an important lecturer in those days, Silver Keeping, had been a master's student of Francis Lewis. Her maiden name was Silver Dowding, and she studied the flora of sand dunes in Alberta. And I used to use her paper when I worked on the sand dune beetles of Alberta. So Silver Dowding had a big influence on a lot of people. She became one of the first female lecturers on campus outside of nursing and home economics, and went on to do her own PhD in Manitoba, came back, worked in the Department of Bacteriology in the 50s and then in genetics in the 60s. She was apparently quite a fun gal. She was a member of the Unitarian Church, and when she passed away, they published this booklet of quotations from Silver Keeping called Silverisms. Wonderful sections. Here's a little bit about reproduction without sex. Important reading in these difficult times. She also had pithy, insightful things to say about the nature of science itself.
What is science? Since I've done rather a lot of it, perhaps I ought to know the answer. Well, let me tell you, fundamentally it's fun. It is exciting and all-absorbing, for you see, it's been built on the firm foundations of curiosity.
Silver Keeping.
I didn't know Marcy. I think, I met him. And when I came, I think his Flora of Alberta was in press. It was published in 1959, and he wrote The Flora of Alberta. But that was a very fine early contribution to our knowledge of the vascular plants in Alberta. It's an excellent flora. I thought about bringing it up to date, so it was 25 years subsequent to that we published the second edition, 1983. Included all the new species which had been discovered in Alberta, and there's quite a number of those. And there were changes, of course, in nomenclature, and we actually included maps. But the basis of it was the original flora of Moss, and the basis of his original flora was the collections that he'd made. He established a very fine collection, a herbarium at the university. And now we have, 50 years later, we've got about not quite 114,000, but we got over 100,000 specimens in the new herbarium, which is of course in the Biosciences building. You should take a little walk through there.
Then came Professor Rowan with a brand new MSc. He became his own department with the name Zoology. He performed his bird experiments. He talked on the radio. He was the greatest ornithology guy that the city would ever know. Biology, biology at the good old U of A. It comes in many guises, but it never goes away.
I mean, it had to be the smallest department in the world, I think. The zoology department was simply Rowan, Moore, and Miller.
The first zoologist at the University of Alberta was William Rowan. He was a very talented man, a talented scientist, a talented artist, these are his sketches behind me, and a talented writer. Born in Switzerland, Rowan was educated in London, England at the University College, and he came here with a BSc and an MSc, which I find very inspiring because it's the same qualifications that I have. It was a time of great opportunity, and he was given his doctoral degree well into his career as a professor.
Rowan would come in and give a lecture. What do? He'd reach in his pocket, he'd pull out these notes, and then they'd go and give his lecture. The following 2 days later, he comes in and pulls out his, and he gives the same lecture again. But he's so interesting, and it has a different slant to it, but it's the same lecture. Nobody stopped. Man, what eloquence. Rowan was so eloquent. Man, he was eloquent. And you were just glued to whatever he had to say.
William Rowan had a variety of interests. For example, he was keen to understand the population cycles of some kinds of mammals, but he was most famous for his work on bird migration. He began experimenting with juncos, little gray and white sparrows, but Rowan was a showman, so he wanted something bigger, something flashier. He chose crows. Now, in order to do experiments with crows, first of all, he had to go out and get experimental crows from the wild. So he and his assistant, Bob Lister, spent a lot of time out at Beaver Hills Lake trying to catch crows with great, huge screen traps. And eventually, they settled on a method using padded gopher traps. Now, they would take a gopher trap and they would pad it with the rubber from tire inner tubes and weaken the spring so it wouldn't break the crow's legs, and then they'd bait the gopher trap with rotten eggs. They captured their crows, they brought them back to Edmonton and kept them in great screen cages right next to the high-level bridge. And because there were only 2 bridges in Edmonton at the time, everyone knew about Professor Rowan's crow experiments. As the winter wore on, he tricked them into thinking that perhaps spring was on the way by leaving the lights on above the cages a little bit longer each day. And then, in the middle of winter, he let them all go. He announced on the radio that his experiment was in progress. The crows had been released, and he asked people who either saw crows or shot crows to report back to him on where those crows were. He plotted the data out, and sure enough, most of those crows were fooled. They went northward in the middle of January, possibly to their doom, but he had unlocked the riddle of migration, the importance of photoperiod, and on the basis of that, one of the first truly experimental studies in zoology, Rowan became a very, very well-known figure.
You know, Rowan had a clause in his will about his skeleton. He had specified that his body would be skeletonized and that his skeleton would then be mounted intact as an intact skeleton. Somebody told me that he actually wanted this thing, his skeleton, mounted and standing there in the department.
This is not Rowan's skeleton. It has a label on it that says it came from the Carolina Biological Supply Company, and it doesn't have a cigarette.
My understanding is that the body was then sent to another university where it was prepared as a skeleton. And
Still out there teaching someplace.
well, the story I heard was that it did come back, but it's not going to be on display.
You can't leave Rowan alone because he was very, very interested in communicating. He's a great teacher. And he built the collection first as a teaching collection. It's only been since that time that research has contributed a lot to the collection. But, we still have things like the platypus, the echidna, the tuatara from New Zealand, things that are either difficult or impossible to get. They're a legacy for a long time. That'll last for many generations. We don't know how long museum specimens can last. In the oldest European museums, there's specimens that have been around for hundreds of years, and we have far better facilities to store them in today. So what he started could go on for millennia if mankind lasts that long.
Now, the story of Professor Rowan really isn't complete without some mention of Bob Lister, who was his longtime technician. Lister worked with Rowan in the field. He prepared specimens for Rowan. He did a lot of very hard work. And in those days, that didn't even get him a single mention in Rowan's book. So it's not surprising that Lister wrote his own book, which was published in 1979. It was called The Birds and Birders of Beaver Hills Lake. It really should have been called My Adventures with Professor Rowan. Lister clearly had great admiration for Rowan, but on the other hand, he also portrayed him as a stubborn, difficult man, a pompous man who was continually getting a car stuck in the mud, driving on the wrong side of the road, getting them kicked off people's farms. Apparently, he would just come up to the farmhouse and announce, "I'm Professor Rowan. I suspect you've heard me on air and know about my bird experiments." And if people had heard of him, then he would announce his intentions, and if not, he would just simply leave. In any event, the story of Professor Rowan, it's very, very interesting and part of our heritage, and it's fun to read it from both sides of the story.
Entomology, of course, and the grand old Colonel Strickland. And man, what an impressive man he was,
Colonel Strickland led the charge for the study of the bugs. Neither he nor Dr. Hawking had much time for mush or hugs. Still they built a great department, the finest in the land. Way off in agriculture, they took an entomological stand. Biology, myology, at the U of A. It comes in many guises, but it never goes away.
Have a look at this beautiful collection of Alberta insects. This is a particularly nice drawer full of geometrid inchworm moths. This collection was put together in the 1920s by Colonel Strickland. Look at that, every specimen beautifully hand-labeled, beautifully prepared, carefully identified. Colonel Strickland was the first entomology professor on campus, and of course he was a military man. He was a veteran of World War I, where he was wounded in France in 1918. Then he came here to teach entomology in the Faculty of Agriculture, but he also ran the Canadian Officer Training Corps on campus during the 1930s. Then when World War II broke out, he took a leave of absence, went down to Wetaskiwin to train soldiers there. So he had a dual career, partly here on campus, partly in the military. To his senior colleagues, Colonel Strickland was just known as Strick, and he was a good friend of Professor Rowan's. They used to go hunting together at Beaver Hills Lake, although apparently Rowan rolled the car twice with Strickland as his passenger, after which Strick decided that perhaps he would do the driving. Now I should tell you as well that Colonel Strickland spent 7 years in Lethbridge before he came to Edmonton, and there he was the head of the Dominion Laboratory of Entomology, which sounds very impressive, but really it was a one-room operation in the attic of a sheep barn when it first started up. From what we know of Strickland, it was clear that he was a dedicated, impressive, and also a compassionate fellow, the sort of person you would have really enjoyed learning from or working with. I also remember a friend's mother in high school, when she found out I was interested in entomology, she said, "Oh, I remember Colonel Strickland. He was so handsome and such a good dancer." And you just knew that Colonel Strickland was an impressive fellow indeed. You know, it's hard to imagine what it must have been like learning entomology from a teacher of military discipline, but back then that was the norm. The second entomologist at the U of A was also a military man. Brian Hawking arrived here after a stint in World War II in India as a military entomologist. Now, Hawking was a brilliant scientist. He was a very prolific writer, and his books live on today. Six-Legged Science, an introduction to entomology for a general audience. Biology, the Ultimate Science, which of course it is, and the somewhat pessimistically entitled Biology or Oblivion, Lessons from the Ultimate Science. This was a fellow who truly believed in the value of biology.
He was a very enthusiastic and inspiring teacher, I can tell you that. That's how I got switched out of zoology, where I was a pre-med student, into entomology.
Brian Hawking had just become head. Colonel Strickland, who was the first head of the department, had retired that year, and it was a two-man department. And Strick was head, and then Brian became head, and I became the other guy.
Brian Hawking had a big enough name, and in those days the U.S. Army were putting a lot of money into research on mosquito problems because they had soldiers over in mosquito-infested places. And so we were one of the only departments, I think there was one other in Ontario, who were drawing a U.S. Army grant at the time to do research on this biting flies.
Shortly after the war, by about 47, lice that were resistant to DDT had started to show up. Brian Hawking got some money from the Defense Research Board to reinvestigate this possibility for control. What he decided to do was to find out how strongly louse could grasp a fiber. What he did was he took these lice that he'd harnessed up and he tied them to this thing. This is a torsion balance, and it's a way of weighing very small objects. He had a binocular microscope set up, and down here he had these pieces of cloth made with fibers of different diameter, and they were stretched and lice were placed on that. To me, the whole military application or the public health application of this is not half as interesting as the evolutionary aspect, that you've got these lice out there that have evolved with hosts over millions of years, and they've got claws that hang on, and they hang on very well to hairs of a certain size, and the hairs of their hosts.
No, it's spectacular.
Yeah,
It's really interesting basic research.
Well, that was Hawking. The Hawk wanted to, get all this stuff, and And he did it. He did a lot of experimentation with stuff that was hand-built. But the guy you got to speak about when you speak about entomology is George Ball. When he took over as chairman, it was a great, great thing following Hawking, because we thought Hawking was the best. But Ball was the leader, and of course, ex-Marine. A lot of people don't know, and I didn't know until his 80th birthday, that he got the Purple Heart. And I never knew anything, and not too many people knew anything about it.
A group of us, of course, we have coffee breaks a couple times a day. I think the younger staff don't really care for this sort of thing. But I grew up in wartime, and people were working in factories and so on 12, 14 hours a day. And so these coffee breaks were essential. And so having grown up that way, I still believe they are essential. And so we have them. It's a tradition that's carried on for, I guess, 50 years.
Entomology was always a small department. In fact, over its entire history, there were only 11 professors of entomology. They liked to emphasize quality over quantity. It was also part of the Faculty of Agriculture originally, which then became the Faculty of Agriculture and Forestry, and the entomologists only joined the Faculty of Science when all the departments were merged together. I think they were perfectly at home in the Faculty of Science, though, in part because most entomologists on campus have been basic scientists rather than applied scientists.
There was a student from Egypt called Monib Tawfiq. He was just finishing up when I got here, and he was working on bed bugs, and he had a hell of a time trying to get them to feed, take a blood meal. You know, rabbits and stuff, but they wouldn't feed on them. So he finished up strapping the boxes to his arms and his legs and what have you. So he was walking around feeding those bed bugs on his legs and arms. And the guy got pernicious anemia. He just losing so much blood that he got sick, but something you can recover from quick.
So I don't know, do you remember this part of the building? Did you spend much time here?
I do. I think I had my parasitology lab in here.
Oh, right,
Parasitology was always a good one to tell your friends, yeah, I'm learning about parasites.
Oh, unbelievable stuff.
All about it.
Yeah, and some of the profs even grew their own parasites, like their own tapeworms. Did you know that?
Within them.
Yeah.
Yeah, I kind of guessed that just by looking at them.
You had to read the labels carefully to see where the worms came from, but yeah.
And I'll always remember people in those days, before they set up the animal place here where they supply rabbits and that, people used to up with the sleeve and in with the arm into the cages of mosquitoes when they wanted to feed them. And so when we were doing mosquito research, we had cages and cages of them around.
Well, there's some areas some areas of biological science which didn't even exist when we started. I mean, all this molecular biology was we're just on the verge of that. In 1954, we had the classic Watson and Crick paper in Nature, and that was 54. That was since I've been here. No, it was just after I got here. Just after, and things. That was another impetus for the explosion in biological sciences and the increasing number of people that were appointed in the area and the great number of students that came.
Then around the time of Watson, around the time of Crick, genetics had arrived. The molecular clocks began to tick. Soon enough, those old plant breeders jumped the fence and climbed aboard. Suzuki hopped off early, but his fame was still assured. Biology, biology at the good old U of A. It comes in many guises, but it never goes away.
Now, the history of genetics at the U of A goes way, way back. to the Faculty of Agriculture and the formation of a Department of Plant Science in 1917. In those days, well, people didn't really understand how genetics worked, but they knew enough to use genetics to develop new varieties of crop, for example. Crops that were more resistant to pesticides or that were better able to tolerate the Canadian climate.
The first PhD programs at the University of Alberta, if I have all my information correct, were in plant genetics. In any department, there were a lot of master's programs in various departments, but the first PhD programs were at the University of Alberta in plant science. And they were initiated by a gentleman by the name of Dr. John Unroe, an internationally renowned geneticist who became the chairman of plant science. And that's, with his appointment, that is when genetics started really on this campus.
The geneticists didn't form their own department within the Faculty of Science until 1961. And that was a very exciting time. Let me try to put it in perspective for you. The discovery of the role of DNA in genetics didn't happen until 1953. That's only 8 years before our Department of Genetics was formed. Watson and Crick got their Nobel Prize in 1962, only a year after the department was formed. So everyone felt that they were on the absolute frontier of science. They were also aware of their role in the neo-Darwinian synthesis. And this was a synthesis that began in the 1940s of various areas and elements of biology that had been kind of separate before that. Things like paleontology, ecology, and of course genetics. And it was a geneticist, Theodosius Dobzhansky, the Russian-American great scientist. He worked, I'm very happy to say, he worked on the taxonomy of ladybugs as well as being a great geneticist. He gave the synthesis its motto when he wrote, "Nothing in biology makes sense except in the light of evolution."
In '61, the Department of Genetics and Plant Science in Agriculture was established, and Clayton became the first chairman of the department. You could not have wished for a more reasonable person. He supported his staff, he broadened the base of teaching and research, and he brought 3 staff in short time. You may not know that one of the first people he brought in was David Suzuki.
Oh, I have lots of fond memories of my first class. When I got here, I was a low man on the totem pole, and I had to teach a group of Aggies. I said, oh God, I'm a hotshot geneticist. I don't want to deal with those agros. They were the greatest class I ever had. 15 boys, 1 girl. They worked their heads off, and we played their heads off. It was great, and I loved that class.
Genetics is a basic science with practical implications, right? If it stayed in agriculture, I think a lot of people were pushing for what I may call an imbalance, with a lot of practical applications and not as much basic research. We said, let's move to science, do the basic work, and then have some practical applications wherever it's thought possible. We wanted to incorporate all of these new biochemical and molecular findings into our basic offerings, advanced undergrad, and grad courses. We wanted to make our program at the teaching level the best there is in this nation, in the only genetics department in this country.
Trouble was a brewing back in medicine in those days. Stewart's pipe was sending signals, and the smoke said, "Go away." The path to Paranchuk was paved with sweat and tears. But in science, the microbiologists had some 32 really good years. Biology, biology, at the good old U of A. It comes in many guises, but it never goes away.
Well, now let's talk about the Department of Microbiology. I like the story of the Department of Microbiology because it has the most amusing written record. This wonderful booklet called The Path to Paranchuk, written by James Campbell. Bill Paranchuk was one of the chairs of the Department of Microbiology. And here we find out that microbiology had its roots in the Faculty of Medicine and the Department of Bacteriology. And in those days, the chair was a fellow named R.D. Stewart. And he was the sort of person who believed that microbiology should be conducted by medical people in the medical clinical tradition, not by basic science microbiologists who were becoming a bigger and bigger part of his department. So eventually, the basic science microbiologists, led by Gordon Myers, left bacteriology, came over to the Faculty of Science, and started their own department.
But I think it was much more fragile earlier in the 60s as a spin-off or a split from medical micro. If you know the story that very much as many departments started on campus, one or two people that the university accommodated by setting up departments around them, so plant science and botany, animal science and zoology.
The microbiologists were happy to get away from the attitude that PhDs are just expensive, glorified technicians, but shortly after they formed their own department, they became part of a new plan by the Dean of Science, Don Ross. He wanted to merge all the departments of biology together because he thought there were too many departments. They'd been formed simply to appease people, to smooth over battles over either personality or undergrad teaching or how you define your discipline.
I mean, Ross tried a couple of times to incorporate all the various parts of what he thought an undergraduate plan for biologists should be.
And he chose a young hotshot microbiologist, Wilfrid Rizal, to come and head up first of all the Department of Microbiology, and then the plan was that he would become the chair of the new merged giant department. Rizal thought this was a dandy plan until a particularly tense meeting when the entire Department of Genetics stormed out of the room in protest. Unfortunately for Rizal, he only stayed here for 3 years.
Splitting and merging is a factor in life of universities, I think, where strong individuals pull things together and then other individuals see their future or the future of their discipline as being different.
When the merger eventually happened in the 1990s, I don't think it was any surprise to the microbiologists.
I mean, it basically comes down to the changeover from the Getty to the Klein government and the big cutback. And we were told by the dean at the time, Dick Peter, that remember, this was a time when there was a threat to dissolve the dentistry faculty. So the cutbacks were very real, and all provincial employees took a 10% rollback, and this included university people. So we were told that our department could not be protected, I think was the phrase that the dean used, if we didn't merge.
1994 was the year of the great merger, when 5 departments, botany, zoology, entomology, genetics, and microbiology, came together to form biological sciences, or biohuge as some people called it. For some, it was the end of an era. There was much gnashing of teeth. For others, well, it was a new beginning. And for still others, especially undergrad students, it went by more or less unnoticed. You got your degree from the zoology department, but the year before it was merged with 4 other departments. Yes. Was that something that was important to you as a student or your fellow students?
I had no idea that it even merged. I had no clue.
Biohuge. I think it's taken on a name, sort of a fun kind of connotation, much like the Butter Dome, which was first very negative comment about the building, but now everybody loves the Butter Dome. And I think we're quite fond of Biohuge as well.
I feel very comfortable here, but the building was user designed, so every floor, every office was designed by the people that were the original occupants. And of course, when new people come in, they want to rearrange things. So a lot of renovations have taken place over the years.
When I became chair, one of my main goals was to support the museums and make sure that there was staff for them. We've tried to renovate them, get them up to Canadian museum standards.
You know, this is not understood by many people elsewhere, but having a museum collection of material in a university for undergraduates, I think is vital, because I think it's vital that students in biology learn the importance of the species, know what a species is, know how to recognize a species, identify species. I don't mean just on sight. That would be impossible, we have too many. But at least appreciate the importance of identifying material down to the species level and having some idea of what a species is and knowing something about its natural history. So the museum is fundamental to all of this, in knowing how to identify things, learning how to identify things, and seeing some of the diversity in the material that we have.
I think they represent the history of the department better than anything else. I mean, you can line up papers published in journals back 100 years or whatever, but there's nothing more tangible, I think, than the museums and collections.
Joe Nelson, he's certainly been the greatest collection builder. You know, most of our specimens are fish. Joe Nelson's collected many of them himself, or he's brought researchers and students here that have brought fish with them. Our fish museum is outstanding. You know, it's not a major state or national museum. And in that regard, it's the biggest collection of its kind in North America.
I love to go to the greenhouses and see the living plant collection, the Strickland, even the cryptogamic which to my untrained eyes looks like dried spinach in brown envelopes. When you look at the extent of the collection, it really is remarkable. And then you talk to the people who know about the collections, and they can just reel off the names for thousands and thousands of different species.
When the museum moved from the Earth Sciences building, the cockroaches came with the collection. And we had quite a battle with them for years because we had an autopsy room right beside the museum, and there were always animal bits there, and the cockroaches, of course, could find their way into the carburetor and get them, and if there were any little bits on the floor, they'd find them and thrive on them, you know. We haven't seen cockroaches there for so long. Sometimes I miss them.
Yeah.
You pick up your sandwich at lunch, you're not sharing it with a cockroach anymore.
Wow, I think there is so much happening to the environment now that, and we have to, we're the canaries, us guys that studied the critters. And water, of course, a big issue. Air is the other big issue. And I think there's a wonderful opportunity to get into those fundamental needs of living creatures, including ourselves, of course.
I think as an instructor at a university, our main contributions come through our students, not directly from what we do. We're only one Homo sapien, each of us, but there are hundreds and thousands of them. They're brilliant. They're in all these fields. And if we have a positive influence on them, we can make a major contribution, not directly, but through them. And I think that's the way most instructors, I think, make their contributions.
We're about 300 graduate students, and we have about 140 teaching assistants now in the department. We have many, many students that have scholarships. Right now we have about 11,000 registrations in the department, about 500 specialization and honors students, and about 1,500 majors in biology. So huge numbers of students. One of the things that we do here that is rather unusual in Canada is we have a lot of labs in our courses, and I think this is giving students terrific experience in biology that they may not get at other large institutions.
I always thought that being a zoologist, whether you are a practicing zoologist or not, just studying life sciences would enrich everybody's life, anybody's life. They'd understand the world around them better, appreciate things they saw so much more if they had a deeper understanding of them.
I guess I'm just looking over there and I see pictures of my former students. That's what I'm most proud of. the people who came here to work with me and what they managed to do after they were here.
Being a student of the things that interest me. This is great. And as a student at the undergraduate level, as a graduate student, as a postdoc, as a professional in the real world at the Canadian Museum of Nature, and a professional now among the professoriate here at the University of Alberta, I still get to play student every day. And it's a different learning experience every single second. So if that is what makes for a great career and a happy life, that's the walk I'm walking.
You know, I like to think that reconstructing history from photographs and documents is a lot like reconstructing the past from the study of fossils. If you don't get the fossils out of the ground, carefully prepared and into the museum, they erode away and they're gone forever. So whoever you are, think about leaving a bit of a legacy. Keep a journal, write down some stories, take photographs, take pictures of each other, the buildings, the labs. After all, that's what they'll go to the next time someone wants to recap what's happened here. Now, we've gotten through the 1st century, but that's just a warm-up, a mere blink in geologic time. Who knows what the next century or even the next decade is going to bring. It's a wonderful, wonderful, rich heritage that we have here, and it's clear this is a first-rate university for the study of biology. And of course, it's nice to look to the past for inspiration, but the truth is, the future is in your hands, and I think it's in good hands as well.
Biology at the good old